Hello YouTube family, James Green, short series Shenanigans, part 2 of the gear cutting that we're working on. So, as you guys know, with any project that we get started with, we mean everyone in general, you always, no not always, a good majority of the time, especially us garage guys, you have to stop and either fix and or build or make something, repair something to continue the project. So, also Mother Nature got involved Sunday. This is actually Monday now when I'm shooting the part 2 to it, because I planned on shooting it and uploading it Sunday. Mother Nature got involved with a very nasty lightning storm, so bad that it even hit a power station north of here and knocked out power for a lot of the middle part of the state, literally. So it was out for a few hours. After that I was like, you know what, it's still lightning, I don't want to come out here and touch equipment. So after that we got out here early this morning and worked on it and made, I had a piece of, and part of it, and by early I'm talking like well after midnight, I have several of these old boring bars that hold the square steel, rectangular, whatever, some type of quality metal. There's some stamping on it, whatever. I have a bunch of these that, you know, in various lengths. Some of them are kind of bent. This one I remember was kind of bent at the end. It had a Morse taper like 4 on the end, and I just cut it off because it was like bent right at the taper. Wasn't good for a boring bar anymore for that. So I've been using these for building tool holders or arbors, because very, very good quality steel. Now, earlier today in my live Facebook thing that I do at times on Facebook, I'll show some stuff. I tested the arbor that which is the same steel that I made here for this gear cutter, because I didn't have one that had a 1-inch shank. I had 15/16 and I had 1 1/16 and all around, so I had to make one. Long story short, this is some very hard metal. I tested it with my PT2 hardness tester, and I'll show you what I'm talking about here, because I have everybody there to ask, okay, are these worth it? My opinion, instead of having the big, huge, giant 300-pound hardness tester, those things were good back in the day. I am a big fan. This is made by PT2 Instruments. It's the model 316, and it's a Rockwell hardness tester. And what it has in here, and I've showed this before, it has the hardness tester, it has a NIST traceable scale, has the tool that makes the dent, and this is what reads the mark. So I was curious, because it was really, really hard metal, and I've never tested this, so I didn't know exactly how hard it was. And I double checked it. Actually, I actually checked on the end of the material on the shaft. I checked it and reread it after I shot that video this morning, because I wanted to make sure I had the correct number. This stuff tested out at 52 on the Rockwell scale. So very, very hard material. So anyway, long story short, it was very adventuresome to machine this. The reason I wanted to use this material, and I knew it was really, really hard, instead of just some, because I have some 4130 and 4140 floating around, I wanted it to be rigid and stiff. And that's why I've been saving this, because I've made other arbors out of it in the past. So we made us an arbor here. I've got our gear tooth cutter, so we had to stop and make the arbor before we could go on with what we've got. I've got you guys set up at a pretty decent angle. I'm going to move you around here. And I've got the air conditioner running and the fan running. So I apologize if you might hear a little wisp of a fan blowing. I'm trying to keep air circulating. We're supposed to be getting some more rain later tonight, but I should be able to get in here and get this done before the lightning starts again. That's the game plan anyway. So I'll show you what we got set up here. Okay. Now what I did was, I'll go ahead and move in here a little bit. And I've got my zero mark, so I can go ahead and back out. Move this down a little bit here. Okay, that's enough there. Now what I did was, because I want to make 3, let me explain why I'm doing this, why I'm doing what I'm doing. Okay, we're going to be making this replacement gear. What I've talked about before, sorry, this gear, as you can see, is worn paper thin, worn the hell out. 5/8 ID. The toter major diameter is approximately 1 inch, 275. So I made this. It's actually one solid piece, and so I don't have to recreate, make one, take it off, put another, make one, take it off, whatever. I wanted to make 3 of these in one shot. So what I did was, I took, and you'll see some grooves, is I parted down below the level of the teeth beforehand, so we still have material in the middle here that's holding all 3 of these together. So as I cut, when I go to part, I don't have to worry about accidentally breaking some gear teeth. So I've parted off below the level of where the gear teeth are. So what's holding it is this inside material. So all I'll have to do at this point, throw it back on the lathe with my arbor set up, go in and finish parting off. I thought about that rather than make one, do it off, do all the rotation, and doing that 3 times. I thought, let me make 3 gears at once. Now, the reason I'm making 3 gears, I have a habit of whenever I make a specialty item, if I can, I will make more than one. The reason we're making 3 is Stan Zikoski, shout on HKW, go check his channel out. Or if you guys know Stan, you know what I'm talking about. He has the exact same machine as I do. So I told Stan, hey, when I'm doing this, I'm going to make you a new shaft and copy this, because I know his is probably worn out just as bad as mine is. So that way it's like, while we're doing it, so I've already made Stan the shaft. Okay, there's your shaft already made, ready to go. And it actually goes on this handle here. Okay, it slides in, needle bearings, that's a new needle bearing, and of course I had to make that new collet, that bearing presses in there, and I still got to do some work to it. So it's like, while I'm making this stuff, let's go ahead and do it ahead. So what I did is I just had a short piece of 41, now I've got it on here already, and it's got a bit of a shoulder in here. I made this long because I've got several cutters. I looked through my box, I have several cutters that are vary in thickness, and so it's a this is a reduced shank down to 1 inch, and in here it has been relief cut so it'll slide over and push up against and lock this in. Or if it gets fatter and sticks out past the threads, I can just flip this over, endo it. It's just got 2 flats, nothing fancy, but it's locked on. So this is that material you're actually using is 4140 chromoly. And we're lined up. The depth of cut that we're going to be doing is 150 thou depth of cut. Okay, which is, I was able to find, estimate approximately the depth of what the gear should be. The rack is still good. Okay, so the rack gear is still good. We're just going to replace the spur gear. We're going to go in here, and we have 18 divisions, I believe. Let me double check so I do not misspeak and lead people astray, because at times we all get carried away. Where's my marker? Pull the marker out. And there's my marker. Alright, so here we go. So let's count just to make double sure. So I do not, because I try to be a stickler about making sure I give the correct information. Okay, so let's count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You take 18, let's just do the math, so we do not confuse anybody out there in internet land. And someone called. Who called? Who missed the call? That's funny. Alright. Pull up my calculator. So we go 360 divided by 18 equals 20. Now, I do this just because at times some people are just, they're human calculators. I do it longhand or with just to make sure I'm correct. So I've already got my dividing head on 0, so we're going to go 20 degrees in between each rotation 18 times. Of doing that should get us all the way around. Let's go ahead and get started. I'll move up close, and I'll just, you guys aren't gonna, I'm not gonna show making the entire, doing all the cuts on video, because that'll take, we've got like, what, 20 minutes left, but we'll go ahead and show you what we got going. Let me go ahead and get everything set up here, and we will get started. And we're running slow, we're running 80 RPM. Let me step over here and fire up the American Rotary Phase Converter, our ADX series. So that's the phase converter running. Whoop. We'll go ahead and get started. Oh. There we go, because we're in back gear. Alright. Come up here and get to make sure our 0 is still good. Yep. Add just a little oil here. Now I could do flood coolant, but we'll try the oil here for a little bit because it's soft. So there's 10, 15, 20, 25, 30, 35, 40, 45. Still cutting good. 50. Now what I will do off camera is I will run flood coolant, because I know it'll try and make a mess and you won't be able to see anything, because I'll put like a splash shield and I'll do all that. But for right now, we'll do this like this with just spray oil. There's 50. 70, 75, 80, 85, 90, 95, 100 thou right there, and we need to be 100 and, what did we say, 150 thou deep. Double check, make sure. Yep, 150 thou. 105. 10, 15, 120. 125, 130, 135, 140, 145, 150. Alright, 150. Table's locked in. And now we're just going to slowly feed the table in. Down the way there. I'll get you guys kind of watch me. And I'm going to feed this by hand. But I will, when I do this off camera, I'll set up my flood coolant. And we'll cut this. And if you don't have flood coolant, you just do like what I'm doing. And you can hear it. Just listen to your machine as it putters along. got our power feed on real slow. Now that we're cutting, it's not going to take much, and it's just creeping along. Barely moving along. Don't get in a hurry. We're not trying to do anything super fast production here. Power feed right on the verge of, I don't want to run it too fast and cause a tool crash. I'll move you guys around, get you a better view here. It's just creeping along real slow. Keep the oil to it. Now I had this vise set up over here because I was still having to do some mill work, and I didn't want to tear my setup down again and have to redo it. So that's why I had this mess clamped up here on the end, because I still needed to do some items. So rather than set this up and tear it down and do it all, I'm like, well, I can just set this up on the end, and I actually had to do it to mill my flats on this big nut and a couple other things. Worked real good. Hey, if it looks stupid and it works, it's not stupid. I don't know, we'll see. We'll cut these, and if they're not correct, then by God, we'll make some more. But I've got some old bearings and stuff in here on the ends to kind of space things out. And I tried to turn this nut down here on the back enough to make sure it's clear, so if we cut into the nut, because it's made of the same stuff, it's not a showstopper. And it's cutting into it a little bit, and that's fine. We're going to go ahead and loosen our table. We'll back out. Shut it off. Go ahead and loosen our table a little bit here. You guys can see the cut we're getting. I'll zoom in a little bit. Going through there. Just going to back the table off over here. And we're going to crank it around 20 degrees. So there's 5, 10, 20. Lock the table down. Oh. Come in here and I'll touch off, make sure everything lines up on 0. Yep. And we'll just slowly feed in till we got 150,000. A little oil. Like I said, when I go to do the rest of these off camera, I'm going to actually run flood coolant. So that way I keep a steady flow. And you know, doing this 20 times is going to take a while. There's 100 thou. 110, 115, 20, 125, 130, 35, 40, add a little, 45, 150. Lock the table. Power feed engaged. And away we go. Oil, oil, oil. We'll see when we get done how well this works, but make 3 of them at once. How we'll do it. Repeat it over and over and over and over and over till we go all the way around. So this is a 16 diametrical pitch with a 14.5 degree pressure angle is the gear pitch for this gear that we're cutting, and that's the cutter we have. Again, normally, like I said, I normally do flood coolant when I'm doing this, but for filming purposes, I'm going to do it like this. I figure for a couple passes on camera it would be okay. We're not going to hurt the cutter. We're not running too fast. It's soft material. It's 4140. So, but I will set up splash shields on this side and this side, run my flood coolant, and I'll just get with it. And I should be able to gen along pretty quick. And we're almost done with the second cut. Like I said, doing stuff like this on camera at times can get a little nerve-wracking because you're trying to do what you pay attention to this and then talk on camera, so at times it's kind of, oh man, I hope it don't mess up. But we're going along good. That one's looking good. Go ahead and unlock the table, back out. So there you go. You guys can see there's 2 passes. And I know it's not really exciting for some of you guys. Others, it's pretty cool. Well, I'm not gonna show you cutting all of these on camera. Let me get the camera back up here because it can get kind of boring after a while. Let me shut the phase converter off so I don't have to talk over it, just in case, because I know it can sound loud on camera. In all reality, it's not loud. I think my fans in the background are louder than it is. So yes, just so you know, my American rotary phase converter that I have, it's over here. The ADX series, I love this thing. I can run Gertrude, the Boyer Schultz 6x18 surface grinder. It has a 2 horsepower motor. It has the hydraulic pump motor, which is a 1/2 horsepower. Again, 223 phase. And then Bridget's single horsepower motor, all at the same time. And just to kind of fill a little time, just to show you guys, we'll go ahead and do it. I'll fire it up, and everything's back enough. We'll go ahead and fire up the mill, and then what I'll do is I'll go ahead and fire up the grinder, and you guys can see I can run both. If I wanted to, I can run both at the same time. Okay? So let's go ahead and fire up Bridget. You guys heard her running. Everything's clear. Power feed's disengaged. Everything's clear. Go ahead and start it up. All right. It's running. All right. Let's fire up. Move this out of the way. Let's fire up the grinder. And we don't have anything on the plate. We'll fire the spindle up first. See, the grinder is louder than that. And now we'll do the hydraulic pump. And we'll go ahead and you guys, and I'll just cycle the table back and forth to turn the light on here. Now we'll just cycle the table. So it'll run both at the same time, no problem. You know. So another reason to have a rotary phase converter. If I wanted to run a part and then come over here and do some quick work on my mill, like if I really wanted to like play this crazy game right now of grind something and cut the gear, if I wanted to be that daring, I could do it, but it'll handle it. So another reason to get a rotary phase converter. Move that back over there out of the way. And let it spin down. And then we'll kill that. There we go. So, right there, if I was to have to put a VFD on here, and see, you can't run a VFD on here, and I don't know if you could, it'd be kind of difficult, and run the pump, both of these, because you'd have to adjust everything, because you have a hydraulic pump, it's not a manual, it's a manual and hydraulic, so you'd have to have, who knows what, you know, the higher the horsepower VFDs, the more expensive they get, but both pieces of equipment at the same time if I wanted to for this shop. But still, if I had, let's say if my lathe was 220 3-phase, if it was 3-phase, you know, which it's not, but I'd have it wired over into it if I needed to. But for these two small pieces of equipment, my Bridgeport has a 1 horsepower, this has a 2, and then it has a 1/2 horsepower on the pump. So running them, no problem. I was grinding something the other day, just test piece, and turned the mill on and running it, and was just sitting there running the mill just to see. It handled it fine, no problem. So again, gotta love the American Rotary Phase Converter. So when we get done with this will be all for like the gear cutting for now, but I just wanted to go through and explain everything. It's a lot of monotonous, repetitive, and redundant and repeating. Kind of get where I'm going with this for cutting the teeth on the gear. So whenever we get done with this, I'll come back and I'll show you. It'll be like, we won't call it a part 3, but it'll be the assembly of when we get all this put together for the surface grinder here. So I hope you guys have enjoyed it. If you have any questions about this video in reference to, you know, building gears and stuff, there's a lot of information out there. You guys ask me, I'll answer the question to the best of my ability. Thanks for watching. Again, like I always say, and I truly do mean it, take care of yourself and your family, because at the end of the day, you and your family is all you got. While you're at it, go to www.allindustrial.com, call them, say, hey, I need a master catalog, and ask for a free t-shirt, and they'll be sure and give you one. All you gotta do is tell them James Green sent you, and they'll hook you right up. They're going to be updating their new website here shortly, and lots of new exciting things coming from All Industrial Tool Supplies. So you guys take care, and we'll see you on the next video. Bye-bye.